Hello students, how are you all? I hope you all are fine. See here what is written, types of matrix. So today we are going to learn about the how many types of matrix are there, how we will define a particular type of matrix. So see here, all types of matrix written here, row matrix, column matrix, zero or null matrix, singleton matrix, horizontal matrix, vertical matrix, square matrix, diagonal matrix, scalar matrix, identity unit matrix, equal matrix, triangular matrix, two types, upper triangular, lower triangular, singular matrix, non-singular matrix, symmetric matrix, skew-symmetric matrix. Okay, so we will discuss one by one each type of matrix. Okay, so let us start our discussion about the type of matrix. Okay, so see here first type of matrix is row matrix. Okay, so row matrix means from the word row, it is clear that there will be single row. If there is single row in a matrix, then that matrix is called as row matrix. So in this matrix is defined as A is equal to Aij. A is equal to Aij of order 1 cross m. Sorry, 1 cross n. 1 cross n means here number of 1 represent number of row, or you can define matrix in which only one row is there, then matrix called called as row row matrix. For example, if you will take for example, suppose 1 2 3 4. See, in this only one row is there and column may be different. So only one row is there. Matrix called as row matrix. Now let us see the next one, column matrix. Column matrix just opposite of row matrix. Column matrix will be A is equal to Aij, in which m into 1 will be. 1 represent number of number of column and it is defined as matrix in which only one column is there matrix called as column column matrix. Okay, for example, if we write this element in column 1 2 3 4 and so on, to see here only one column is there and different rows are there, so number of rows may be different but column will be only one. Okay, now let us see the third one is zero or null matrix. Zero or null matrix. Zero or null matrix means there will be a matrix A in which Aij m cross n, Aij will be equal to 0. If each element of a matrix is 0, then called as null matrix. It can be defined as 0 0 0. For example, 0 0 0 0 0 0. It will be represent. Okay. Suppose that you are writing 1 minus 1 2 minus 2 3 minus 3. Okay, so this is called as zero or null matrix. Or you can define matrix in which all elements are zero. Then called as null zero matrix or null matrix. Okay. Now we will see the singleton matrix. See here, singleton matrix. Singleton matrix is cleared as from the word single. Only single element is there in a matrix, then called as singleton matrix. It is defined as A is equal to Aij Aij, where m and n will be equal to 1. Okay, m is equal to n is equal to 1. Only one element is there. Whereas you are defined a is equal to only a is written, a is equal to b is written only, a is equal to 2 is written only. So this is called as singleton matrix. Only single element will be there. Okay. So see how you will how four types of matrix defined. Now let us see the next type of matrix. So I'm going to erase. I hope you have noted down. Okay. Just pause the video and note down. Now let us see the next type of matrix. Now see the next one is horizontal matrix. Horizontal, horizontal matrix. Horizontal matrix is cleared from the word horizontal. Means there will be number of rows will be greater than the number of columns. Okay. So in this matrix is defined as A is equal to Aij, where m cross n such that where m cross only horizontal will be there, so m is greater than n. M is greater than m. Okay. So if m is greater than the row will be greater than column. Suppose for to write here matrix in which number of rows is greater than number of column. Okay. So for example, how you will write? Suppose you are writing 1, 2, 1, 2, 3, 4, 5, 6. So in this you can say there is and this matrix is of order 3 cross 2. 3 cross 2 means there are 3 rows and 2 columns, and here 3 is greater than 2. So satisfying the okay horizontal. So in this way you can define the horizontal matrix. In this, number of rows will be greater than the number of columns. Okay, mean horizontally you can write. Okay. Now see the next one. Next one is vertical matrix. Vertical matrix. Where a vertical matrix is just opposite of this matrix. Matrix in which number of rows is less than number of column. Number of column. That is A is equal to Aij m cross n, and m is less than n. Okay. For example, how you will write? Suppose 1, 2, 3, 4, 5, 6. Now in this you can say this matrix is of order 2 cross 3. In this, number of column is greater than the number of rows. So that's why it is called as vertical matrix. Okay, so vertical line will be there greater, and this horizontal line are greater. Okay, so in this way you will define the vertical matrix. Now see the seventh one. Seventh one is square matrix. Seventh one is square matrix. Square matrix means matrix matrix in which number of rows is equal to the number of column. Number of rows is equal to the number of column. That is, you can say that A is equal to Aij, where m cross n, m is equal to n will be. Okay. For example, 2, 3, 4, 5. In this, number of rows equal to number of column 2 cross 2. Suppose 1, 2, 3, 4, 5, 6, 7, 8, 9. See, in this order of 3 cross 3. Okay, so in both number of column and number of rows are equal to each other. That's why we called square matrix. Okay, now let us see the diagonal matrix. Next, all type of matrix. So I'm going to erase here. I hope you have understood. I hope you have noted down. So see here. Now see the next one. Next one is what? 8 1 diagonal matrix. Diagonal matrix. So diagonal matrix will be square matrix. Diagonal matrix will be square matrix. Okay. So square matrix means number of column will be equal to number of rows. So square matrix in which elements except main diagonal are zero are 0. It means that is you can say that A is equal to Aij m cross n, m is equal to n. Second thing, Aij is equal to 0 when I is not equal to j, and A is equal to constant will be any value when I is equal to j. Okay, so it can be defined as what? Means any number will be there. Suppose that 1, 2, 3, -1, -2. Okay, any number will be there. Write here any number. Okay, any number. So what you will write? For example, suppose you are writing 1, 2, 3 in main diagram 1, 2, 3, 0, 0, 0, 0, 0, 0. See here. Okay, so this is the form of diagonal matrix. Okay, or you can write 0, 2, 3, 0. Here, this is also a diagonal matrix. In main diagonal, 0 are there and remaining element are any number. Okay, so this is called diagonal matrix. Now see the ninth one, scalar matrix. Scalar matrix. Okay, so scalar matrix is a diagonal matrix. You can see scalar matrix is a diagonal matrix in which diagonal elements, okay, diagonal elements will be constant, will be same or constant. Okay, same will be there. If elements are same, then you can say that matrix is called as diagonal matrix. Okay, so how you will define this? Suppose A matrix is there, that is A matrix is there defined by Aij m cross n. First condition is m is equal to 1 should be, m is equal to n should be there. Second condition is Aij is equal to 0 when I is not equal to j, and Aij is equal to k when I is equal to j. Okay, so how you will write? You can write like 2, 2, 2, 0, 0, 0, 0, 0, 0. So see this matrix. In this, main diagonal element will be constant. Okay, any constant number you can write. Okay, so this is called the scalar matrix. Okay, now let us see the 10th one. 10th one will be what is identity. Identity identity unit matrix. Identity unit matrix you can say as it is a scalar matrix. Scalar matrix in which diagonal diagonal elements will be only one. Okay, or it is called as unit Okay, so called as, and in this way you will define. Okay, so that is, you can say, so scalar matrix in which diagonal element will be 1, it is defined as A is equal to Aij. In short, you can define that Aij, m cross n. First condition is m is equal to n should be there. M is equal to n should be there. Second condition is Aij is equal to 0 when I is not equal to j. Second thing, Aii is equal to Aij, sorry, Aij is equal to 1 when I is equal to j. Okay, when I is equal to j. So in this way you can define. So this can be written as, suppose that one you have written 0 0 0 1 0 0 0 1. So this is called the identity matrix. In diagonal element will be only one. Okay, so in this way you will define the identity matrix. Now we will define equal matrix. Okay, now we will define equal matrix. So see here what is equal matrix. I hope you are noting down all the things. Now see the, which one? 11th one. 11th one is equal matrix. Equal matrix means two matrix whose elements elements are same. Two or more matrix, you can say, two or more matrix whose elements are same, then both matrix called as equal matrix. Okay, in short you can define as, suppose A is equal to Aij m cross n. Second thing, B is equal to Bij m cross n. Both first condition is both matrix should be of same order. Okay. Second is Aij should be equal to Bij. So this condition should be satisfied for the equal matrix. Suppose that you are writing you 1 2 3 4 5 6 7 8 9. Suppose you are writing, okay, and next matrix is given 2 minus 1, 3 minus 1, 4 minus 1, 5 minus 1, 6 minus 1, 7 minus 1, 8 minus 1, 9 minus 1, 10 minus 1. Suppose this matrix is given. So on getting the difference, you will get same element here. Okay. So both matrices have the same element. That's why it is called as equal matrix. Okay. Now we will see 12th one. Next, triangular matrix. Triangular matrix. Okay. So triangular matrix means matrix in which in which elements above or below main diagonal. Okay, in which elements above or below main diagonal are zero. Okay, called as called as triangular matrix. Called as triangular matrix. Okay, it is defined as, how you will define. So in the main diagonal element will be there. Okay, so see here, suppose I am writing here, suppose main diagonal I am writing 1 2 3. Here I am writing 4 5 6 and remaining 0 are there. Okay, remaining are 0 are there. So see, from the main diagonal above elements are 0. Or you can say, suppose 1, 2, 3 you are writing, and suppose this will be 0. Okay, it's 4, 5, 6. So in this, from the main diagonal, below elements will be 0. So both are called as triangular matrix. Now triangular matrix is divided again into upper triangular, upper triangular, upper triangular, and lower triangular, and lower triangular. Okay, so how you will define it? So upper triangular means, let us see here, space is not here. Okay, so that you can understand in a better way. Now see here. So here upper triangular, upper triangular, upper triangular means elements main below main diagonals are are 0. Elements below main diagonal. Okay, below main diagonal. So below main diagonal, this is, you can see. Okay, so here write down 1, 2, 3, 0, 4, 5, 0, 0, 6. So this is example of upper triangular. Okay, and here lower triangular means, lower triangular lower triangular means elements above main diagonals are 0, okay. This is the example of lower triangular. 1, 0, 0, 4, 2, 0, 5, 6, 3. See here. Okay, so you can see in this upside making a triangle, in this low side making a triangle. Okay, by taking the element. That's why it is called a upper triangular matrix. This is called a lower triangular matrix. Okay, so I hope you have understood how you will define the triangular matrix. Okay, so in this you can say here, in this which element a, which element it is indicate that a 31, sorry, a21 it is, and this is a31, and this is a32, and in this what is there, this is called the a13, and this is called a23, and this is called a12. Okay, see here 21 is there, and here, so in this you can, write also in upper triangular matrix. In upper triangular matrix, what you will write? A21 is equal to A31 is equal to A32 will be 0. Okay. And in this, A12 is equal to A13 is equal to A23 will be 0. Okay. So in this way, you can define also Aij. Okay. So see here. Now let us see the next type of matrix. Okay. So next type of matrix is singular matrix. Next type of matrix is singular matrix. Now let us see 13th one, singular matrix. Singular matrix means matrix whose determinant is zero is 0. Okay, suppose a matrix Aij is there, whose m cross n is there, and if determinant of A is equal to 0, then A is equal to Aij, m cross n is singular matrix, is singular matrix. Okay. For example, suppose A B C D E F. is a matrix is there. Okay, so suppose A is equal to this one, so determinant A will be 0. Okay, as you know the property of determinant, if any two column have same element or any two row have same element, then their determinant will be 0. Okay, so its determinant will be 0. This matrix is called as singular matrix. Okay, now fourth one is non-singular matrix. Non-singular matrix. Okay, non-singular matrix. Non-singular matrix means matrix whose determinant is not zero. Is not zero. Okay, is not zero. Suppose A is equal to Aij is there, whose order is m cross n. Then if determinant of A is equal to 0, then A is equal to Aij m cross n is non-singular matrix. Okay, for example A B C D E F G H I. Okay, if you will find the determinant of this, so 0 will not come. Okay, or you can say take 1 2 3 2 3 1. Okay, 3 2 1. Okay, you can take this also example. uh, Determinant of this matrix will be not zero. So that's why this matrix is called as non-singular matrix. Okay. I hope you have understood this type of also. Now let us see the next two one. Symmetric and skew symmetric. Symmetric and skew symmetric. Okay. So skew symmetric means here 50th one. Symmetric matrix. Symmetric matrix means symmetric matrix means uh, if a matrix if a matrix whose whose transpose whose transpose is equal equal to itself equal to itself. Okay, that is, you can say that suppose A is equal to Aij is there of order m cross n. Okay, so A is equal to transpose of A. This is the condition of symmetric matrix. Okay, so in this what will happen? A is equal to transpose of matrix. So in this what will happen? Aij element will be equal to Aj I. Aij element will be equal to Aj and remaining will be any other element. For example, you are taking suppose you are taking that case. Suppose 1 2 3 here you have taken. Okay, so see this is the A12. So A21 will be here. A21 will be here. And see this is A13, so A31 will be here. Okay. Now this thing you can take another value 1 4 5 also in this. Now see here this is the element of A23. So if you will take here suppose 6, so here you have to take 6. Okay. Here you have to take 6. If you are taking the transpose, suppose A is equal to you have taken. Now take transpose. So 1 2 3 transpose means row become columns and column become rows. Okay, 1 2 3 2 4 6 3 6 5. Okay, now see this both compare. Both are same na? Both are same, satisfying this condition. So that's why this type of matrix is called as symmetric matrix. Okay, in this condition should be satisfied. Okay, this condition should be satisfied. Aij should be equal to Aji for symmetric matrix. Now let us see the non-symmetric matrix. Non-symmetric matrix. So non-symmetric matrix means a matrix whose uh, a matrix is equal to negative of its transpose. That is, you can say that suppose that A matrix is there, then minus A transpose of T will be equal to each other. Okay, equal to each other. In this what condition will be satisfied? Aij will be equal to minus Aji. First condition is this. Second thing, Aii is equal to 0 should be there. 0 should be there. Okay, so how you will write? Same thing you will write. Suppose you are writing 1 and II means A11 will be 0. Okay, suppose you are writing 2 3. Now so this is A12, though A21 will be minus 2. Minus 2 will be. Now here again here 0 will be there. After that this is A23, so A32 will come here. Suppose you are taking 4 here. Okay, so this is A31, so minus 3 will come here, and here minus 4 will come here. Here 0 will be there. See, okay. So see, this is A12 and this is A21. So we are taking negative of both them. Na? This is A13 and this is A31. Both are taking, this is A23, this is A32. So both are opposite to each other. Negative is there, satisfying this relation, and Aii. In the main diagonal, all elements will be 0. If you are taking transpose of it, suppose you have taken A is equal to this one. If you are taking A is 18, if you are taking transpose of this, so what you will get? 0, 2, 3 will come here, minus 2, 0, 4 will come here, 3, sorry, 0, 2, 3, minus 2, 0, 4. Now minus 3, minus 4, 0 is coming here. See. Okay, if you take minus of this, if you take minus common from it, suppose if you are taking minus common from it, so what will come here? 0, 2, 3 become minus 2 will be here 4, here minus 3, here 4, 0. Okay, now see, it is coming A. Okay, so A transpose is minus A will be equal to each other, and A is equal to A minus transpose of A. So you can see this matrix is satisfying the given condition of non-symmetric matrix. Okay, so I hope you have understood how you will define the symmetric matrix and non-symmetric matrix. So for symmetric matrix, this condition should be satisfied. Non-symmetric matrix, this condition should be satisfied. Okay, so I hope you have understood all type of matrix. Okay, so if you have liked the video, then share and subscribe it. And if you are facing problem in any question, to take pic of that question and send me that pic on my WhatsApp number. I will make video of that question to clear your doubts. So here I am leaving my WhatsApp number. Note down. Okay. So on this number, send me pic of that question which you are facing doubt. Okay. If you have any query, then comment in my comment box. Till now, wait for the next video. In next video, we will discuss some more related thing with the of matrix. Okay. Till now, thank you and have a nice day. Okay. Thank you.